Welcome to the third installment of building the ultimate Miter Saw Workstation. In this installment, we're going to look at the details that are so necessary to make this workstation, well, work. I love to put laminate on the tops of my work surfaces in the shop. The difficulty here was how to mount this laminate on this lower section once the cabinet was built. So I spent a lot of time noodling through that. I could have probably mounted the laminate to the board before I glued up the entire assembly. I would have had to have left a blank area on the sides about 1/4 of an inch deep to fit into the dados. And that looked like that was going to probably be difficult. Putting the laminate on afterwards also presented some problems though. How to get it flush up to this edge on either side, that was a problem. And then how to get it trimmed off flush on the front and the back. Now normally when you put on laminate, it's really pretty straightforward on a tabletop. You put some glue on the laminate, you put some glue on the top, you let it dry for a little bit, then you stick it down. And whatever is overlapping around the sides, you take your trim router with a guide bit, laminate trim bit, and you just go around, you trim it off flush with the edges, and it's gorgeous. Here, however, if I was to put a laminate trim bit into a router and run the router along the edge, as soon as the edge of the router base hit the edge here, that's as far as I could go. And it would leave a section untrimmed over here about half the width of the router base. So how to trim that off? Well, you can cut that off and then use a file and file it down till you get it even with the rest. That's kind of a lot of trouble too, and that's sort of open to making a few mistakes. So I didn't really want to take that risk on doing that once the system was built. So I really noodled through how to do this, and finally what I came up with was I cut a piece of plywood out exactly the same size as this inset portion. Exactly. I mean, I got it exact. Once that plywood was cut out in exactly the same size, I then clamped the laminate to the plywood, no glue, clamped it down. You could use double stick tape as well. I clamped it down and ran the router around and trimmed it perfectly to fit that go-by piece of plywood. Then it was pretty easy to apply the glue, line up one edge, line it up with the front, and roll it into place, and it fit just perfectly, and I didn't have to do any trimming on the front or back edges. Applying the laminate to the rest of the top was really straightforward. Again, just glue it down, use a trim router, and trim the 4 edges off. The next big step though was to figure out how to put in this T-track. My concern with routing for this T-track was really simple. Frankly, I have never routed a piece of wood with the laminate top already attached. And I was really concerned about whether or not it would chip out the laminate as I was routing the groove. And I wanted it to be neat and clean and frankly pretty. So I figured out that I needed to run a test. So I grabbed this board. This is just an old piece of 3/4 inch plywood. This is where I had run test to, this actually was to test for the bottoms of the pedestal cabinets to make sure that I had the width right for 2 sheets of plywood. This is where I ran a little test groove in. This was another test groove I'd cut, but the other side of this was unscathed. So I took it and applied a piece of laminate to it. And it wasn't quite the right size, but I stuck a piece of laminate down to it, and I trimmed it all flush on these 2 edges. And then I set it up on my workbench, set up the guide rail and the router with the correct size bit. In this case it was a 3/4 inch bit, and I started cutting a groove to see how it was going to work. Well, my first test only went in about 1 inch, and I realized it was kind of a semi-disaster. It was chipping the laminate, it was raising it up a little bit, the depth of cut wasn't right for the T-track that I was using, and the whole thing was a bit too narrow. So I had to rethink. So the next thing that I did, I cranked up the speed on the router. That helped a little bit too. But I was still getting chipping on the sides of the Formica, or the laminate. I set this up as a test, and I got my depth correct, and I went in a little further with each test until I finally got it like I wanted it. And what I found out the key was to use a down shear bit. The down shear bit pulls the laminate down instead of up as it's cutting. Higher speed seemed to work better, and I got no chip out. And since I did it all in one pass, I didn't have to worry about, do something twice, you double your chances for an error. So that was the procedure that I used. I used, again, the Festool router with the guide rail, and I simply clamped the guide rail to the assembled top and ran my grooves. Made sure I got them nice and straight. One of the things that I had determined from prior experience was that I wanted the T-track to be just a minuscule amount below the surface. I like that better because when you slide stuff across it, there's no chance for anything catching on it. The other thing that I wanted to do was I wanted to just ease the edge of the laminate just a tiny little bit. So I just used some sandpaper wrapped around a small block of wood and made a couple of passes at about a 45-degree angle, and that just eased the edge there. So with that done, the next step was to cut the T-track. Now, I'm no master by any stretch of the imagination, but I can handle a handsaw. I can cut dovetails by hand. I got to think about it a little bit, but I can do it. I can cut tenons pretty well. I can cut a straight line, and as long as I use my little workbench fixture, I can even cut pretty good miters. But you give me a hacksaw and a piece of metal, I can mess that up pretty quick. So I was a little nervous about cutting the T-track. And the reason was because I just wanted to get it nice and pretty. I ran to the store and bought a couple of new hacksaw blades. I thought that might help. Didn't really, but I thought it would. And then I tried to figure out how I was going to actually do this. So I turned back to my trusty test board that I had used a few minutes before. Since I had a groove in the test board already, I figured I could clamp this board down to my workbench, slide in the T-track into that, clamp that down, and it would hold it nice and steady. Because the first key to sawing anything straight is to make sure the workpiece is nice and steady. So that was one little load off my mind. And the next thing was how to mark this. So I put it into place on the groove on the Miter Saw Workstation, and I marked my cut location with an X-Acto knife. Made a nice little sharp mark where I wanted to cut it. Then I took a piece of painter's tape and I wrapped that around with the edge of the painter's tape exactly even with my mark. Now, painter's tape, like any other kind of tape, it's cut square. So if you start wrapping and you go around, by the time you get all the way around, if the edge doesn't match the edge where you started, you didn't wrap it square. So you pull it back off and you try it again. And when you wrap it perfectly square, you get a nice perfectly square edge as a go-by for sawing. Then you clamp this into place, follow that edge with your hacksaw, go nice and slow, take full long strokes, don't press down too much, and voila, you get a pretty clean cut. The only thing that I had to do was there was a couple little sharp edges of metal that I used a file and just filed those down smooth. And then I turned that around and mounted it into the tabletop, and it worked out just fine. This particular T-track has holes drilled through it and countersunk every 4 inches. So I used wood screws. I used number 4 wood screws that were 5/8 of an inch long to mount the T-track. Now, you could epoxy glue this T-track into place. I really didn't see it as necessary on this because I'm not going to be mounting any jigs or anything that's going to be pulling up on the T-track. It's simply going to be for mounting the fence. So I think the screws will be plenty, especially since they're every 4 inches on the T-track. With the T-track, the fence done, laminate on, the last thing to do was to put the saw in place and mount it into position. Now obviously with any miter saw they give you the ability to bolt it down into place. I could have drilled all the way through this top assembly and simply bolted the saw in place. But I wanted something a little bit more elegant than that and decided instead to use threaded inserts. So I wanted to install threaded inserts in this top and then use these little fixture deals to mount the saw. So this makes a pretty elegant way to do this, but then the question became, how in the world do I mount those threaded inserts into this laminate covered top and get a neat clean job? So once again, I turned back to my test board. My first attempt was pretty ugly. I simply chucked up a brad point bit and went to drilling, and it chipped out the laminate all the way around and made a pretty nasty looking hole. So then I switched to a Forstner bit. Forstner bit gave me a much better hole, but then when I tried to screw in the threaded insert, I was still getting it lift on the laminate and a little bit of cracking around the edge. So then I used a countersink and chamfered the edges of this hole. Then I was able to screw in the insert and get a nice, neat looking installation. Right now the saw is in its forwardmost position. It's very close to the front of the table. And the reason for that is because it's easy to get to, it's easy to see, it's easy to work with. There's plenty of light. It's easy to make adjustments because it's close to the front of the table. And because it's close to the front of the table, I can only cross cut about 7 3/4 inches that's fully supported by the table. But the saw will do in excess of 12 inches. So I moved the saw back and made 4 additional holes so that I could install the saw in a rearward position when I'm cross-cutting large material. Now, 95% of the cuts I make are in material that's 6 inches or less in width. So having it in this forward position is very comfortable and easy. But then on that occasion, when I need to cross-cut a 10 or 11 or 12-inch board, I can simply move the saw back, move the fences back, and have a fully supported workpiece. Now this whole top assembly is incredibly heavy. And then you put an almost 100-pound saw on top of it, and it's really heavy. So the likelihood of the top moving on the pedestal bases was pretty slim. But I moved my equipment around a lot. And I wanted to be absolutely certain that the top could not move on the base. The simple answer to that was these draw catches. They're like what you might put on a chest or a box, and they worked out just fine. I've got 4 of these on each pedestal. And anytime I do a project, the one thing that I always do is sort of a post-mortem and say, what would I do differently if I were to do it again? Couple of things here that you might want to consider if you build a Miter Saw workstation for your shop and you use any aspects of this design. It was suggested to me that rather than have two sets of mounting holes for the saw, I should put in T-track, and then I could move the saw forward and back any increment that I wanted to. That actually is a pretty good idea. If I were to do it over again, I might actually do that. One of the things that I thought about too late, after I finished constructing the top, I've got two vertical components in here. You can look at the plan and see about where those are located. Had I moved those vertical components out a little bit and left a space in the middle, say 13 or 14 inches wide, this would have been a nice little drop-down door or a drawer to store spare blades for the saw. The last thing that I might consider doing differently were I to do this Miter Saw workstation again is I might leave out this vertical component here on this side of the table. This is a relatively small section, and I'm not sure that that vertical support is actually necessary, and this would give me a much larger drawer on this side. And a larger drawer might be handy instead of these 5 smaller drawers that I've got now. I still think the vertical supports on this side are important because of the size of this, but maybe 1 in the middle instead of 2. Those are all things that could easily be changed should you decide that you wanted to build this Miter Saw workstation. I hope you enjoyed this video building a Miter Saw workstation for your shop. And I hope if you're using your Miter Saw on top of plastic saw horses or another saw bench, that you'll consider building a dedicated Miter Saw station for your Miter Saw. One of the things that I've found out since building this is the cut quality that I'm getting has actually improved. And there's a pretty good reason for that. Any piece of equipment that you have, vibration is a factor in the accuracy of the cuts that you get. Vibration can be damped through mass, and this Miter Saw workstation has a lot of mass, so the vibration is significantly less, and I've noticed that it actually runs a little bit more quietly than it did before. Also, the long fences make for very accurate cuts and a very stable workpiece, so I think overall it's safer. I like the white top because I'm getting a lot of reflected light and it makes it easier to see things. I like the saw in the forward position where I can sight easily the sight line for a cut. I like the ability that I can move the saw back and cut really wide work pieces when I need to. All in all, I think this worked out pretty well. Could it be better? Absolutely, and I think when you build one, you'll make it better. So be sure and send me a picture if you do. See you next time. Thanks for watching. See you in the next video.